Hey guys, Mr. Sonnenberg here. Today what we're going to talk about is the periodic table. This is for you Science 9 students that are studying matter and chemical change, our second unit of study in the curriculum. So this is going to be topic 5 in your textbook for study references to help you better understand the material. So first we're going to talk about this guy by the name of Dmitry Mendeleev. Now Mendeleev is the one who is credited for building the periodic table. He took the atomic mass of elements that were known to him at the time, and he basically rearranged them and ordered them based on some of their properties or that atomic mass, and was credited with creating the periodic table. But back then typically scientists worked in isolation, but he actually worked with a guy by the name of Mayer from Germany. He was a German man. And what happened was in 1869, because Mendeleev actually published his findings first, he got the credit for creating the periodic table. So what he did was he took he took 63 elements that were known, arranged them based on their atomic mass, and then he wrote them on file cards. So basically a card that looked like this, had its name on it, maybe atomic mass, and he wrote some information on these cards, and he laid them out on a table, and that's why it's known as the solitaire-like table. He laid them out and he rearranged them, and he was sorting them, trying to understand where they would go in terms of arrangement. So that's why I have this deck of playing cards up in the corners, because that's almost what he did. So you just want to remember, almost like cards. So if you were to play cards, play solitaire, and you lay cards on top of each other in an arrangement in solitaire, that's basically what Mendeleev did with the periodic table. He also knew, though, that there were gaps, and he knew that there was elements that weren't discovered yet. So he actually he left spaces on his table because he knew these things would be discovered at a later time. So if we were to look at an individual element, we have to talk about different components. So what does all this stuff mean right here? Well, this stuff means, so this is going to be called your atomic number, and this stuff's going to be really important, so pay attention to this. This might be a good time to start writing some things down. This is going to be your symbol. This is going to be your name, so it's hydrogen. This is your atomic, where's my mass? Good. Okay, so this is your atomic mass. So I would pause the video and I'd make sure I write these things down. I would draw this diagram, I'd write it down in your notes, because this is going to be important in terms of determining what we're talking about next. So now what we need to talk about are these numbers. What do they represent? Well, the atomic number is going to represent the number of protons, which are positive, charged, and the number of electrons, which have a negative charge. Following? And then there's also another thing we're going to talk about that are called neutrons, that have no charge. Yeah. So they have no charge. Okay, so again, I would pause the video and I would write this stuff down. Okay, so these neutrons that have no charge, what's the point of those? Why do we have those? So we know we can determine electrons. We know there's one proton based on the atomic number. We know there's one electron. And now how do we tell neutrons, how many neutrons there are? How do we tell that? Well, we're going to take the number of neutrons, pretty simple, number of neutrons, and it's going to equal, we're going to take this mass number now right down here, the mass number, and we're just going to subtract it by this number up here, the atomic number. And that's going to tell us number of neutrons, atomic number. So mass number is going to be 1.0079 minus 1. It's going to equal 0.0079. So that's how many neutrons. Now remember, neutrons have no charge. Okay, protons are positive, electrons are negative, and neutrons have no charge. So if we take a look, some of the things we've discussed so far, atomic symbol, we know that that's right there. Atomic mass, or the mass number, or atomic mass, we know that's right there. And atomic mass is a little different. The mass number is going to be the sum of protons and protons and neutrons. Okay, so that's what that is, sum of protons and neutrons. And then we know the atomic number is up top there. Okay, so that's how we can use that information to further use the periodic table to our advantage and to understand things. And you need to know that in high school. So here's a copy or a list of the periodic table. We know that on this side there are metals, and this side non-metals, and right through here we know those are metalloids. Okay, and so we can separate them based on their physical and chemical properties or physical properties, but that's how the periodic table works. So we break that periodic table. So we had that whole periodic table. Now let's break it down. So we have two things we're going to look at. The first one are vertical groups. So vertical groups going up and down like this. And there are 18 of them. 1, 2, 3, 4, 5, all the way across from left to right. And there's 18 of them, numbered 1 to 18. These are vertical groups. Now, there's 8 of these vertical groups, and again, I hope you understand this, but there are 8 of these groups that are going to help us to understand what this means. Now, valence electrons are the outermost ring. So if we look here, anything that is bolded in black is the outermost energy or electron shell. So we look at the nucleus. I'm just going to color the nucleus in. Okay. And now I'm going to erase it. There's 5 protons in there. So we know, because it says plus 5 protons. Protons, there's 5. So how many electrons are there? Well, electrons, protons, same number. There's going to be 5 electrons. How many neutrons are going to be? Well, we could determine that if we wanted to look at the periodic table and look at the atomic mass, but we're not going to go there. So valence electrons, what are those? So that's the outermost ring. So like I said, we have 1, 2, 3, but we only have 5 here. Well, that's where we draw these diagrams. So I have my plus 5 protons. Now my first electron shell can only have a maximum of 2 electrons. I'm going to draw those with red dots. So 2 electrons in the first electron shell max. And that's really important. The first electron shell can only have 2 max. Now the next rows after that can have a max of 8. So I draw my second shell because, well, I need 5 electrons. I only have 2. So how many do I have left? Well, I have 3 left. So now those go on the second shell, which can have a max of 8. Okay, so we can, these 8 rows, if we take a look at the 8 colored rows, those 8 rows from left to right are going to, we can just quickly look and say how many valence electrons or electrons in the outermost row. So if we take a look at right here, well, there's 3 valence electrons. So we know that, well, if we go over here, we go 1, 2 in these colored rows. So it would be 1 and 2. And then if we go over to 13, okay, well, we know that there's going to be 3 in here. 3, 4, 5, 6, 7, 8 valence electrons. And again, that's the outermost row. So boron would be in this group here. And then silicon has 4. So it would be in this green here. And there's 5 here. So that would be in this light blue color here in that group. So that's groups we can look at easily at those 8, 1 and 2, 13 to 18. So 1 and 2, and then 13 to 18, using this method with valence electrons. The last part of the periodic table we're going to talk about is periods. Now, periods, okay, are going to be your horizontal rows going from left to right. Okay, groups remembered. Groups went left to right, but this is going to, oh sorry, groups go left to right. Let's just cross that out. Groups go left to right, but periods are going to go vertical, up and down. So we'd number these 1, 2, 3, 4, 5, 6. There's 7 of them. I didn't put the 7th one in there with this diagram. No big deal. So there's 7, just to show the point, going from top to bottom. Okay. And so what we're going to look at with these are the number of electron shells. Okay, so the number of electron shells, if we look here, well, the red is 1, blue is 2, green is 3, and yellow or brown or orange, whatever color you want to call that, is 4. So there are 4 electron shells in chemical symbol is potassium. Okay, so there's 4 of them. So we're going to go down 1, 2, 3, 4, and we can determine that potassium is in the 4th row, so it's going to be in this green row somewhere. But if we look back to what we know about groups, then we can look, well, where's the valence energy? Well, the valence is going to be, or the outermost ring is going to be in this brown. So we count how many electrons are in the brown. Well, there's only 1. So if we can go 1, well then what group's it going to be in? Well, we know that it is going to be in group 1, and it's in row, or sorry, let's just get rid of that, period 4. So if we go group 1, period 4, then we know it's going to be, potassium is going to be right here. So if we go back to the periodic table and we do the same thing, we're going to see that, oh, there's potassium right there. Group 1, row 4. Okay, so that means that it has 1 valence electron, and it has 4 electron shells. Okay, so that's how we're going to determine placement. Now, again, for these 2 groups here, we can do that. Actually, I'll erase that. For these 2 groups, it's a little easier right here. So we can go 1 and 2, and these groups here. But the ones, these transition elements, becomes quite difficult, or a lot more difficult to understand. So grade 9, understanding these and these, just understanding how the periodic table works, we can better understand. So if this one has 4 shells, this one must have 5 shells, 6 shells, 7 shells, 3 shells, 2 shells, 1 shell. Okay, so that's how we understand that. These columns, okay, so that has 1 valence electron, 2, 3 valence electrons, 4, 5, 6, 7, and 8. Okay, so hopefully this has helped you to understand a little bit about the periodic table, and we'll also do some labs and such to help you out and to better understand the periodic table. All right, thanks for tuning in.